All right, last but not least, you need to understand the proportionality of this gravitation equation. Here it is again. And we did this before with circular motion, where we asked ourselves how the force would be affected if we changed some of the other variables. And we need to know that here. We want to know how the force of gravity changes if we change the masses or the distance between the objects. G is a constant. It's never going to change. So here's what we need to do to solve these problems. First of all, number one, first of all, for these problems only, you can drop the G. You can get rid of this gravitational constant. That can go away because it is a constant. We're never going to change that number, okay? So we're just looking at the changes in these three variables right here. So we can drop the G, and then second of all, consider that, to start with, consider that everything is 1, right? And here's what I mean by that. If I make both masses 1 and the distance 1, what is my force? Well, 1 times 1 divided by 1 squared gives me a force of gravity of 1. So that's going to be our baseline, right? That's where we start. That's where we know that, I might want an L in there. That's where I know I'm coming from, all right? And then the last thing you do is change what they want you to change and then solve it. Here's what I mean by that. Let's look at the first one. If one of the masses is doubled, what happens to the force? Well, this was our baseline. We know that the force is 1 at the baseline. So if we double one of these masses, let's see what happens. So mass of 1 stays the same, and then we're going to double the other one, and it becomes 2 instead of 1. R still stays the same. That gives me a force of 2 newtons. It was 1. Therefore, that means if I double the mass, I also double the force. Hopefully that makes sense. Double the mass, double the force. And that should be easy to see looking at this equation, because these two things, there's an understood one under here, these two are directly related to each other. Whatever you do to one, the same thing happens to the other. Pause the video for a minute and go down through these other 4 and see if you can figure out what the answer is. All right, with number 2, we started with a baseline of 1, and then let's change what they want us to change. If one mass is halved, well, keep the first one, half the other one, so instead of 1, we get 1/2, and R stays the same. This gives me a force of not 1, but 1/2 Newton. So if we half one of the masses, that means the force is also halved. So that's the answer there. And that means with these two, that means that the mass is directly related or directly proportional to the force of gravity. Let's look at the third one. If both masses are doubled, what happens to the force? This gets interesting. We're going to make both of the masses 2 instead of 1. Radius stays as 1. And this gives me a force of 4 newtons. So if we double both masses, the force itself actually gets quadrupled. You don't have to memorize these things. It wouldn't be a bad idea to, but you can always do this to figure it out. If the distance is doubled, what happens to the force? Well, now we're going to make the masses 1 again and double the distance, so it's 2 instead of 1, and remember the squared. This gives me a force of 1/4 of a newton, or 0.25 newtons. So if we double the distance, the force is cut by 1/4. The force is 1/4 of what it used to be, in other words, which is probably not intuitive. If you double the distance, force is cut by 1/4. Those two things don't seem to be related to each other. But I think we should know, just qualitatively speaking, that distance increases. That means we get farther away. The force should go down. And that is true. It used to be 1, now it's 1/4. Lastly, if the distance is halved, masses now stay the same. Distance is cut in half. So instead of 1, it is 1/2. It's still squared. 1/2 times 1/2 gives me 1/4. And 1 divided by 1/4 gives me a force of 4 newtons. Once again, not intuitive. If you half the distance, you will quadruple the force. You need to know how to work these types of problems.